So let's review these notes from the other day. Remember when we're talking about the n and m, we're talking about the highest exponent of the numerator and the denominator. And what we have to remember for graphing for the horizontal asymptotes, I'm just going to go over horizontal. If n is smaller than m, then the line y equals 0 is the horizontal asymptote. If it is equal, that is where we are going to take the coefficients. And if n is greater than, it has no horizontal asymptote. So let's go ahead and find the vertical and horizontal asymptotes right here. If I have to find the vertical and horizontal asymptotes, first of all, I know the vertical asymptotes are in the denominator, and if I make that equal to 0, I know this could be factored to be x plus 1, x minus 1. If I set both of those equal to 0, notice when I solve, x is equal to negative 1 and x is equal to positive 1. The next thing that I look at for the horizontal asymptotes is the n and the m. In this case, n and m are equal. So the horizontal asymptotes, we are going to take the coefficient 2 over the coefficient 1 and set that equal to y. 2 over 1 is equal to 2. So we have found the vertical and horizontal asymptotes. I'm just going to graph them a little bit for you. The vertical asymptotes would be here and here, and the horizontal asymptotes would be y equals 2. So it's actually kind of convenient to graph these. You can use, obviously, a graphing calculator, but if you weren't given one, you just kind of have to know what's going on in each of these spaces. This graph, I'll actually graph for you. If I plugged in some numbers, this graph is going to be like this, like an upside-down parabola in the middle. So if I plugged in numbers, I would know that this never goes over 0. And then like a rational expression over here on the right and on the left. So once you start plugging in numbers, you start to know what the graph looks like. But let's answer the question here. What are the vertical and horizontal asymptotes? The vertical asymptotes are when I make this equal to 0. Well, notice in this case, we get a negative number. Well, when I take the square root, my negative number is now imaginary. Okay, you can't have an imaginary number, so in this case there are none. There are no vertical asymptotes. Horizontal asymptotes. It tells us that when n is less than m, the horizontal asymptotes are what? Y, oops, didn't mean to do that. Y is equal to 0. I'm not going to graph this one for you. All right, the last question we're going to do, we're going to talk about a new concept. This concept is called holes. It says to find the vertical and horizontal asymptotes in any holes in the graph. First of all, let's go ahead and factor this. What are the factors of 9 that add up to be 6? X plus 3, x plus 3. Very good. On the bottom, what are the factors of 3 that add up to be 4? X plus 3, x plus 1. So immediately you see things that can cancel out. If you can cancel out, that is what creates what we call a hole. So let's go ahead and cancel out our x plus 3, x plus 3. So I know there is a hole when that is equal to 0. It would be a negative 3. So at x equals negative 3, there's what we call a hole. Now to find that actual point, we want to plug in negative 3. Well, if I plug in negative 3 with what's left, I have negative 3 plus 3 and negative 3 plus 1. So I get 0 over negative 2, which is equal to 0. So there's actually a hole at negative 3, 0. Now, let's talk about the vertical asymptotes. Because these canceled out, we know that the vertical asymptotes will only be right here in the denominator. The vertical asymptote will be at x equals -1. And just a reminder, when I'm looking at the n and the m, in this case, the n and the m are equivalent, so my horizontal asymptotes will be coefficient over coefficient, which in this case is y equals 1.